Good morning, everybody. This is Mr. McGee. I'm making this video so that I can clarify a lot of the problems that I'm seeing with students trying to measure the Predator engine. So before we begin, I just want to make sure that we have everything that we need to start this. Number one is our instruction sheet with the items that we're supposed to be measuring. We need to make sure that we have a set of small hole gauges. We need to make sure that we have a set of T gauges or snap gauges. And we need to make sure that we have a set of micrometers covering a range from 0 through 4 inches. And of course our Predator engine. And the last tool would be our feelers gauge. So the first reading that they want us to do is to measure the piston ring end gap. There's two different piston rings that we're going to be measuring. The first one being the compression ring, which is the lighter of the two thin or the two thick rings. The second one is our scraper. Now, what we've got to do here, excuse me if I can take this camera and see if I can't zoom in a little bit. Maybe, maybe not. So we're going to lower our camera down to get us closer to the cylinder. We're going to take our compression ring and we're going to put it in with the back first. Then rotate it carefully. And we want to make sure that this piston ring is in uniform. So we take the piston, take the rings off it, and we're going to push our piston down in there, down to about the wrist pin. And what that's going to do is that's going to ensure that that piston ring is in there exact, so it's not crooked. The next thing we do is we take our feelers gauge and we're going to start out with a small numbered feelers gauge. Now I'm going to start out with a 4/1000 feelers gauge, and I'm going to go down in there to where that ring gap is, and I'm going to measure to see if the 4/1000 fits in there. Bring this up close maybe so you can see it. So that the 4/1000 fits in the ring gap, and it does. So 4 fits, then we're going to try a 5. And after a 5, then a 6 and a 7 and so on. And we want to find the maximum thickness feelers gauge that fits in that gap. Now I'm going to try a 7. And the 7 just fits. It fits so well that I'd bet an 8 will not fit, but I'm going to try an 8 anyhow. It's looking like right now the piston ring end gap for the compression ring is 7/1000. But here goes an 8 anyhow. We'll try it out. And the 8 does not fit into the gap. So, compression ring end gap, 7/1000. We're going to write that as 0.007. Piece of cake. Now we have to do the same thing with our scraper ring, which, as I said before, is the darker ring. Same thing, we're going to put it in there. We're going to take our piston, we're going to push it flat down to the wrist pin, and then we take our measurement. So that should clear up those two measurements for the compression ring and the scraper ring. The next thing that we have to measure on here is our piston to cylinder clearance. Now this is actually a two-part measurement. When you think about things here, which is going to be larger, the piston or the cylinder? Obviously it's the cylinder. So the first thing that we want to do is measure the cylinder. So we're going to get out our T gauges. We're going to select the T gauge that fits in the cylinder correctly. I personally recommend, for accuracy, that you put your T gauge on a slight angle snug it up, and then carefully pull it straight so that it is right in line with the cylinder, and then remove the T-gauge. Take your micrometer, and I believe this is a two and some odd inch cylinder bore. So we simply take our T-gauge and we're going to measure it with our micrometer. Putting the T-gauge in the micrometer, carefully tighten the thimble down until it just touches the T-gauge. Right there. Lock it. Now by now you all know how to read the micrometer. So you know you have a 2 to 3 inch micrometer. So right off the bat, we're going to put down a 2. Then we're going to note the amount of tenths of an inch, which is 7. Hopefully you can see this in the video. Then we know that there's 2 quarter or 25 thou increments. So that'll be 0.025, 0.025. And it looks like 4 thousandths. 0.004. Now we add those up, and that's going to be the cylinder diameter. So 5 and 5 is 10, and 4, that's 14. Carry the 1, 2, 4, 5, 7. So our dimension for the cylinder is 2.754. And we're going to write that's for the cylinder so that we know. The next thing we need to do is measure the skirt of the piston. So again, we take our micrometer and we measure carefully, lock it, and we're going to write that one down. This is the only way you can find this difference. All right, so I have 7 or 0.2, 0.7, 0.025, 0.025, and what do you know? I've got 0.004. Now I'll tell you what, if you can do that, if you can be that accurate, you're pretty good. Typically, the cylinder clearance is about 1 to 1.5 thousandths of an inch between the piston and the cylinder. But we do the math, we have 2.754. Actually, the piston should be about 1.5 thousandths smaller. So we're trying to find the differences. So the cylinder would be larger. We want to treat this like a subtraction problem. We're going to subtract the piston from the cylinder. So 2.754 minus 2.754 equals